Hello, I'm Gerard Fisher from RAP, and I'm directing the project at RAP on the development and implementation of buying guidance and specifications for buyers and specifiers of electrical and electronic products in the retail sector. As part of this work, we've developed summaries of different product categories in order to identify where failure modes are occurring and how they can be avoided through specifying components, design, and user guidance best practice. This webinar will focus on vacuum cleaners. After reviewing the project objectives, Paul Goodman of ERA, one of the technical experts who's helped to develop this product summary, will talk through the key highlights of the summary. Finally, I'll conclude the webinar and discuss next steps and where to find further information. Through RAP's Electronic Products Pathfinder Group, industry recognised the need to identify design changes needed to increase the life of selected electrical products by bolstering durability. The end result will be guidance development for technical managers, buyers and suppliers to provide industry standard accessible content. A first step has been to research the most common failure modes within the product summaries, which provide a first step towards the development of more detailed guidance documents. In partnership with the Pathfinder members, we've selected washing machines, fridge freezers, vacuum cleaners, microwave ovens, kettles and televisions for assessment in these product guidance notes. The structure of the summaries is the same for each product and will include an introduction on how to use the document, the short-term failures that may result in a product being returned to you, the long-term failures that prevent it from reaching its long-term life, and then best practice in terms of component specification, design and user instructions. Finally, it will identify the opportunities for lifetime extension. So now for more detail on this product, I'm handing over to our technical expert.
Vacuum cleaners have a variety of short-term faults that can occur. They can be designed poorly so that the cleaning performance is inadequate. This could be caused by the wrong sort of motor or fan, the nozzle or the airway could be too narrow, filters may be ineffective so the dirt gets through, all sorts of different reasons. It's the overall design of the vacuum cleaner that creates good cleaning performance. Same with the noise level. Some vacuum cleaners are very noisy, and this is called by poor design. It's due to the airway shape. Sometimes it's caused by a lack of sound insulation, or maybe the motor is just too large for the type of vacuum cleaner. Airways can become blocked. Again, it could be because they're too narrow, or the sharp bends in the pathway for the air, so the dirt builds up and causes the blockage. Brushes can become clogged. This is fairly common, but what's necessary though is that they should be designed so that they can be easily removed and easily cleaned. Otherwise, the customer is going to return the vacuum cleaner. Motors can overheat. This shouldn't happen. If it does, it's called by poor design. Possibly not using them properly, maybe because the bag's completely full, they don't realise, or maybe a blockage somewhere in the system. Well, also many varieties of long-term failures that can occur. The motor itself can fail. The motor obviously needs to have a certain lifetime that you'd expect for a vacuum cleaner motor, but if the brushes are too short, they'll be worn out before that lifetime is reached. Parts of the vacuum cleaner can become broken if they're not sufficiently strong. They need to be made of the correct sort of plastic and with the correct design for them to survive the life. Now, the hose material is important because it needs to survive a reasonable length of time, but it may not last the full life of the kettle, so it should be replaceable. Electrical faults can occur. They shouldn't do, but they do. This can be caused by poor quality parts that are not up to the job. It might be due to the design of the vacuum cleaner or parts of it and how it's assembled. With upright vacuum cleaners, there's a lock to hold them upright. That can break if it's not durable enough. Cylinder vacuum cleaners, you often have a rewind mechanism. Again, they may not last the lifetime of the vacuum cleaner if they're not designed properly or they use the wrong sorts of materials. All vacuum cleaners have belts, so it connects the motor to the moving parts. Again, these tend not to last the full life of the vacuum cleaner should be easily replaceable, and the instructions explain how that can be done. So, best practice for vacuum cleaners is due to a variety of different issues. For example, the component specification. Clearly, you have to use the right sort of materials for the machine, the right sort of plastics. The motor and bearing life has to be easily sufficient for the lifetime that you expect, considering some of your customers will use the vacuum cleaner fairly heavily in that lifetime. The electrics need to be robust. There's plenty of temperature changes, vibration. They need to be able to withstand that without failing. The design needs to be specified so that you get adequate cleaning performance. The parts are suitably strong so they're not damaged. The lifetime of the motor is what you expect, and they won't block up in use or be too noisy. And there are test standards for vacuum cleaners. There's an IEC standard which specifies cleaner performance. Also methods for measuring noise, and some of the safety standards have endurance requirements for certain parts, like switches, which can be used for specifying vacuum cleaners. The user instructions need to explain how to empty bags, about warning lights, what they mean, and also how to replace parts such as the hoses and the belts, and also how to remove hair and other debris from brushes. So vacuum cleaner design depends on a variety of different design aspects of the internal parts and the external parts. Air has to flow through uninhibited, freely, so you don't get blockages by dirt inside the vacuum cleaner, and also the motor doesn't overheat. With vacuum cleaners there are, as I say, performance and endurance standards which can be used to specify the design that you want. But it's important that the supplier demonstrates compliance with those standards by providing test results. In the product summaries, we have provided a number of examples of failure modes, their causes, whether they occur early or late, opportunities for fixing those problems, how that can be done, and the likely cost implications. And on this slide we have 3 examples. Now, motors can overheat, can be caused by blockages or poor design, insufficient air flowing over the motor so it gets hotter and hotter until it fails. Now, it is possible to fit an automatically resettable thermal switch. These cut off power when the motor gets too hot. And then, when it's cooled down, they reactivate to allow the motor to be used again. And of course, your customers won't know why the motor stopped. They'll think the vacuum cleaner is not working. So it's better to fit a sensor that indicates that the bag is full, or whatever the reason is why the motor hasn't stopped working, that it's not actually failed. So the buyer needs to specify to the supplier the design with a requirement for an automatically resettable thermal switch. And there is a standard that specifies those. Cost is only about £1 in the UK, when Europe probably less in China. The centre circuit will be a little bit more expensive, but you see that it has the advantage of informing the user that the vacuum cleaner has not failed, it just needs them to take some action. Motor brushes can wear out if they're not long enough. If that happens, the vacuum cleaner is not going to work. But it's quite simple to solve it just by using longer brushes. You need to specify the lifetime of the motor, how long it has to last. The main switch is important. It's going to be used many times in a year. If it's defective, it will not last the specified lifetime of the vacuum cleaner. It becomes overheated and cause arcing, and that will cause the contacts to wear out. So it's important to specify the endurance of that switch, so it will last the lifetime of the vacuum cleaner. And there's a test method in this standard I've mentioned on this slide, which you can use.
Thank you. Full product summaries for all products will be available for download from RAP's website from January 2014. Full guidance documents will be made available by March 2014, and there'll be further engagement on the format of these documents. For further details, please contact RAP through Claire Ollerenshaw, the project manager, at claire.ollerenshaw@rap.org.uk. Thank you for listening.